Hello everyone, today we will solve some more numerical problems based on Lagrangian equations. The first problem is a planet of mass small m revolves around the sun of mass capital M in an elliptical orbit. If motion of planet is confined in one plane, find Lagrangian and Lagrangian equations of motion. You know that when motion takes place in a plane, then the kinetic energy of the system is given as 1 by 2 m r dot square plus r square theta dot square. In the diagram you can see that small m is the mass of the planet and capital M is mass of the sun, and at any instant let us say that the plane polar coordinates of the planet are small r and theta, so its kinetic energy will be 1 by 2 m r dot square plus r square theta dot square. You know it. The potential energy of the system will be minus g capital M small m upon r, and let us say it is equation number 2. The Lagrangian of the system will be t minus v, so it will be 1 by 2 m r dot square plus r square theta dot square, and minus will make it plus g mm upon r. Let us say it is equation number 3, and this is the Lagrangian of the system. Now we have to find Lagrangian equations of motion, because here the plane polar coordinates are r and theta, so our Lagrangian equation of motion will be in the form of r and theta, as these are the generalized coordinates. So our equations of motion will be d over dt del L over del r dot minus del L over del r equal to 0. Equation number 4, d over dt del L over del theta dot minus del L over del theta equal to 0. Equation number 5. Now from equation number 3 we will find del L over del r, del L over del r dot, del L over del theta, and del L over del theta dot, and we will put these values in equation number 4 and 5. Thus we can find Lagrangian equations of motion of the system. Now the next problem is that the kinetic energy of a system is given as 1 by 2 m x dot square, and its potential energy is equal to bx. Here b is constant. Find Lagrangian equations of motion and also solve it for the value of x. Here, as you know that the kinetic energy of the system is given, it is 1 by 2 small m x dot square. Potential energy is also given, it is equal to bx. Let us say it is equation number 2. Now Lagrangian of the system will be t minus v, so it will be 1 by 2 m x dot square minus vx. Let us say it is equation number 3. Here x is the generalized coordinate, so we will find del L over del x dot and del L over del x. Let us say these are equation number 4. So our Lagrangian equation of motion will be d over dt del L over del x dot minus del L over del x equal to 0. Let us say it is equation number 5. When we put the value of del L over del x dot and del L over del x in equation number 5, then we find x double dot is equal to minus b upon m. Let us say it is equation number 6. We can write x double dot is equal to d2x over dt square, so it will be d2x over dt square is equal to minus b upon m. Because we have to find the value of x, so we will integrate this equation. When we integrate it with respect to time, then we find dx over dt, and it will be minus bt upon m plus a constant. Again we will integrate it with respect to time, then our solution comes out to be x is equal to minus b upon mt square plus c1t plus c2. Now the next problem is the Lagrangian of a system is L is equal to ax dot square minus bx square, where a and b are constants. Now find the value of x. Here Lagrangian is given, and it is ax dot square minus bx square. So we will find first del L over del x dot, and it is equal to twice ax dot. Then we will find del L over del x, it is equal to minus twice bx. When we put these values in equation number 1, then we find that x double dot plus b upon a x is equal to 0. It is a second order differential equation. When we solve it, the roots are imaginary and these are plus minus I root b upon a. So when roots are imaginary, their solutions are of the form x is equal to c1 sine c2t plus c3. We know it from differential equations. Next problem is a bead of mass small m slides along a wire which is kept in a vertical plane as shown in the figure. The equation of bead is given as y is equal to alpha x square. Find Lagrangian and equation of motion for the system. Here the wire is in the parabolic form and a bead is sliding along the wire. Let us say at an instant the Cartesian coordinates of the bead are x and y. As y is given alpha x square, so y dot will be twice alpha x dot. This is equation number 2, because the kinetic energy here will be 1 by 2 m x dot square plus y dot square. So we will put the value of y dot in equation number 3 to find the value of the kinetic energy. Then we know the potential energy of the system will be here plus mgy, because here if we consider x-axis as the reference line, then here potential energy will be 0, and because the point P is above the reference line, so its potential energy will be considered as positive. So potential energy is here considered plus mgy. Now Lagrangian of the system will be t minus v, and it comes out to be 1 by 2 m x dot square plus y dot square minus mgy. Let us say it is equation number 5. When we put the value of y dot from equation number 2 in equation number 5, then Lagrangian of the system is represented by equation number 6. Now as x is the generalized coordinate here, so we will find the del L over del x dot and del L over del x. So when we find del L over del x dot and del L over del x and put the value of these parameters in equation number 7, then our equation takes place in the form of equation number 8, and when we solve it further, then our final value comes out to be x double dot 1 plus 4 alpha square x square in bracket plus 4 alpha square x dot square plus 2 mg alpha x is equal to 0. The next problem is a particle of mass small m moves inside a bowl. If the surface of the bowl is given by the equation z is equal to 1 by 2a x square plus y square in bracket, where a is constant, find Lagrangian and equation of motion of the system. Try to solve it yourself. I will solve it in next video. Thank you.